Here we have some function of x given as a differential equation. So we're given dy by dx, and we're asked to find the equation of the curve and to find the value of k. Now, it's probably not possible to find the value of k without first finding y. So y would be the integral of this. So if you like, you can write it the long way. You can say dy by dx equals 6x squared minus kx. And if you multiply both sides by dx, you would have that, and then you can just integrate both sides to find y. So the integral of 6x squared is 6x cubed over 3. And the integral of kx, remember k is just a constant. You don't need to worry about that. Just treat it as any constant. And then because it's an indefinite integral with no limits, we need to add a second constant. So we can simplify that as y equals 2x cubed minus k over 2x squared plus c. So this is a cubic function. But we have two unknowns, two variables, two parameters that we need to find. And we're going to use this information to find it. So because we have two bits of unknown information, we need two pieces of known information, so 2 points. So the first point we're given is the y-intercept. Now, y-intercept means when x equals 0. So when x equals 0, y equals 2. So if we substitute 0 here and 0 here, y is going to be equal to 2. And from that, we can find that c is equal to 2. So you've got 2 equals 0 plus 0 plus 2. So we now know c equals 2. We can now look at the second piece of information that we're given. The second piece of information says it cuts the x-axis. So the x-intercept is x equals 1. So that means when y equals 0, x equals 1. So if we now replace this with the value we found, 2, and now replace x with 1, and y with 0, so that 0 goes there, and that 1 goes there, we should be able to find k. So if we write 0 equals 2 minus k over 2 plus 2, you've then got k over 2 equals 4, so k equals 8. So now we know k and we know c, we can write out the equation of the curve here. So the equation of the curve will simply be y equals 2x cubed minus 8 over 2 x squared plus 2. So that is my k. And I can replace 8 over 2 simply by 4. So that's the answer to part 2. Now the question then goes on to say there's a separate pair of functions. So we've got a cubic and a straight line, and there's a shaded region between them. So we've got this area shaded, and there's some point A and B where the two lines meet, or the two curves meet, and they're saying justify why the area is not the difference of these two integrations. So this looks like the area between x and the x-axis, so between the line and the x-axis from A to B. So that looks like, if I try to shade it, if that's B and that's A, then it's this area. Okay, so this is that area. But notice that this part is below the x-axis. So this part is negative, whereas this part above the x-axis is positive. Then what they've done is they've subtracted the area under the cubic function. So the area under the cubic function is the area here. So I can shade that in a darker color. So that's the area under the cubic function. And again, the area here would be negative, the area here would be positive. So for this part, it's okay. You can subtract something small from something big. And if they're both positive, that's fine. For this part, it's not so fine because you've got something negative and you're subtracting from it something negative. So you're going to get a negative area. So what we should do is split the integration into two. So we should say it's the integral of, say, x cubed minus x dx from a to 0 plus the integral of x cubed minus x dx from 0 to b. Now this is going to be a positive integration, and this will give you a negative integration. So you can either put that between absolute values, or just put a minus sign next to it. Maybe it's safer just to take absolute value. So the area you get here, you make sure it's positive. Because if you don't do that, this is going to give you a negative value. So some people put a minus sign here and don't bother with that. Some people switch these limits just to make sure that you get a positive value. So however you do it, just make sure you get a positive value here. So justify why the area. The answer is because half of the graph is below the x-axis. So you can say because half the area would be below the x-axis and would be negative as calculated. So as calculated here, you'd get a negative value. Okay, it then says find the exact area. That just means doing that, basically. So the integration of x cubed will be x to the power 4 over 4 minus x squared over 2 from a to 0. And we want the absolute value of that. To make make sure we get positive. And then the same again. From 0 to b. Now, a and b are not given. You need to find a and b. It's pretty clear that b is going to be 1 and a is going to be 1. So that's going to be 1 and 1, because that's where the two lines intersect. They intersect when x is equal to x cubed, and that's only going to be when x equals to 1. So you end up with a quarter minus a half absolute value plus a quarter minus a half. So a quarter well, strictly speaking, this should be the other way around. It should be a half minus a quarter, but it's fine because we're taking the absolute value. Quarter minus a half is a quarter, and if you take 2 of those, you get half. So that's your final answer.